So hi everyone, how are you guys doing? First of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, on which is India's largest online learning platform for IIT JEE. And on this particular channel, all the concepts of physics, chemistry, and maths are being taught to you completely in English. Now, this is a series that I'm hosting for class 12 students. This is aimed at helping them revise all the key concepts of most of their class 11 topics and help them through the JEE Mains examination in Feb. Okay, so the topic that we are going to start today is SHM. This is part one of the quick review of SHM then. Now, before we move ahead with today's discussion, let me introduce myself for those of you who might not know me yet. So my name is Rohit Dixit and I studied mechanical engineering from IIT Delhi. And for almost past 8 years, I've been teaching physics for the IIT JEE mains and advanced examinations. And all this teaching so far had been offline. So as a student myself, was All India Rank 447 and All India Rank 192 in the two stages of the IIT JEE exams that I took. I had also qualified the NTC Stage 2 examination and I was in the top 1% in the NSCP as well. I've already coached many students to top ranks in the IIT JEE examinations, and now I hope to continue doing that here online with you guys. Now, how can you guys, you students, hello Supriya, how are you? How can you guys make sure that you are also, powering ahead with your JEE preparation even in this time of lockdown? So you guys can get yourselves the Unacademy subscription. This subscription will give you benefits like live classes where you get to interact with your educators on a regular basis. You have live polls and leaderboards in these classrooms. And of course, you have doubt clearing sessions also, and you have test series and analysis sessions on a regular basis. Now, doubt clearing sessions is a compulsory feature of all Unacademy Plus courses. So every Unacademy Plus course has this feature that every fourth session, so after every three teaching sessions, the fourth session is supposed to be dedicated to your doubt clearing. Okay, so you may ask away any doubts that you may have about your theory or any of your concepts or problem solving. तो जी आपकी कंस्ट्रेंट्स वाली डीपीपी में एक डाउट है प्लीज बता दो तो आज शिवम टुडे इज द डाउट क्लियरिंग सेशन नो एट 6:30 तो उसमें आके पूछ लेना and on plus today's session is the doubt clearing session, right? So you can join that and ask your doubt there. Okay. All right, moving ahead, along with all these benefits, Unacademy subscription also gives you a great opportunity, which is to be able to study from India's best educators from the comfort and safety of your home. So I think that's a great opportunity. Okay, so all the students should definitely try and utilize that. Now, what is the first step towards getting these benefits? So the first step involves हाँ वो फ्लूइड के बट डजंट मैटर उसमें आप ये डाउट भी पूछ लेना that's all right. Okay. Now Shivat says, sir, is there a need to study rotational motion for studying fluid mechanics, SHM, and waves? Not particularly, Shivat. Uh, you don't use the rotation knowledge too much. There are only some questions which would involve knowledge of rotations. That would be maybe like a few questions. That's about it. Maybe 2% of or 3% of the content would probably use rotational knowledge. Okay, otherwise you don't need the knowledge of rotation much. Okay. All right. So as I was saying, the first step towards getting all these benefits is to install the Unacademy app. Now, the moment you do that, you unlock for yourself a lot of free features. So first of all, you have free courses which are running on Unacademy. So that those you can join just after installing the app. Okay, there is no subscription required. Plus, you can attend special classes. So these special classes are free for all students. Okay, so all the educators usually take special classes on the Plus. So I myself take three special classes every week at least. So you can attend those just after installing the app. Okay, you don't even need to buy the subscription for that. तो नेट खत्म होने वाला है प्लीज बता दो तो शाम तक बचा लो नेट शाम को पूछ लेना उस पर आराम से पूछ पाओगे ना यू कैन अपलोड द फोटो देयर यू नो वहां पे डाउट बताना थोड़ा आसान हो जाता है नहीं यहाँ पे थोड़ा सा मुश्किल होगा बिकॉज आई वोंट बी एबल टू सी द फोटोग्राफ नो प्लस ऑफ कोर्स यू हैव quizzes like the ones that we host every Tuesday. So all these benefits of Unacademy you can avail simply after installing the app. Okay. So to unlock all these features, all you need to do is install the Unacademy app and unlock these features with the code RD Live. And that is it. That is all you need. You don't need to buy any subscription for this. तब तक खत्म हो जाएगा। अच्छा ठीक है भाई, अभी पूछ लो फिर, अभी पूछ लो। I will tell it right away. Okay. Then of course, these free features will definitely help you get some idea of how your plus courses and plus experience is going to be. So finally, when you decide to get yourself the plus subscription, then this is how you can go ahead about that. So you can go to the plus section of your app and select your goal as ITJ and click on that get subscription. So with these three easy steps, you will be able to get yourself the subscription. Okay. Next, so when you click on that get subscription page, you will be redirected to the payment page where you will find a box which will say, do you have a code? So that is where you can write this code RD Live. So this code will give you a 10% off on all your subscription fees. Okay. And of course, you can now choose from two subscriptions, which are Plus and Iconic. The fees of all these subscriptions are as mentioned here. Now, you will also realize when you click on proceed to pay, you can also choose to break these payments into a lot of no cost EMIs. Okay. So that will ensure that those payments are easy for you to make. Okay. Now, for people who don't know what the Iconic subscription is, let me just quickly tell you about that. This subscription is a new offering by Unacademy. This kind of subscription takes your IIT preparation to the next level. How does it do that? We allot you personal coaches. Okay, from our team of experts, you are allotted personal coaches. Those personal coaches will closely mentor you and guide you throughout your IIT journey. And apart from that, you will be attending a lot of regular IIT workshops. You will be receiving expert guidelines from time to time. You will be getting a study planner, which I think a lot of students could like to use. And then you will have regular test analysis sessions. Okay, so with all these benefits, you will power through your JEE preparation. Okay, now, for all the students who are entering class 11 and looking for a single one-stop solution for all their preparation needs for their class 11, 12, be it your CBSE, be it your school exams, be it your boards, be it your mains, be it your advanced. So you guys can go for these combo subscriptions. So Unacademy now offers you four combo subscriptions. The first combo comes with the iconic subscription of IITJ and the plus subscription for 11th and 12th. This combo starts at around 4,600 a month. Then you have a combo which provides you iconic subscription for all three. This subscription comes to about 5,500 a month. And of course, you have one combo which offers you all the plus subscriptions. This combo comes at around 3,000 a month. And then you have a combo which offers you the plus subscription for IITJ and iconic subscription for your 11th and 12th. This combo subscription comes to about 3,900 a month. Okay, now with that, let's just quickly tell you this upcoming about the upcoming tests. Okay, the Unacademy Combat is going to happen next on the 17th and 31st of Jan. So make sure you take part of them. Then you have the race exam coming up on the 24th. Then last mile. Okay, this is already over. Then AIM Advanced. This is happening every Saturday, and of course you have unique DPP discussion, which is happening every Monday to Thursday. Okay, so क्या हो गया? Shivam says an aircraft is descending to land at an airport in the morning. The aircraft is landing in the east so that the pilot has sun in his eyes. Okay, the aircraft has speed v and is descending at an angle, and the sun is at an angle above the horizon. Find the speed of the aircraft's shadow moves on the ground. Okay, डाउटनेट वाला अच्छा नहीं लगा, बिल्कुल बकवास सोल्यूशन बताया था, बिल्कुल मजा नहीं आया. ओके, सो यार ये थोड़ा डेटा और बता दोगे तो ज़्यादा आसानी होगी ना मुझे. ओके, ये सर्टेन एंगल जो है ये क्या है एंगल्स, इफ यू कैन टेल मी. अगेन इसीलिए बोल रहा था शाम को डाउट क्लास में पूछते तो बेटर रहता नहीं. Here without the photo of the question, I can hardly understand the question also. Let me see if I can find that DPP. Okay. Okay. No, I don't have any such question in my DPP at least. अच्छा ये रहा. Okay, okay, got it. So just a second, है ना? Let me just get it. Hmm. Just hang on for a second, huh? Okay, I think I've got your doubt here. हाँ ठीक है. मिल गया मुझे. ठीक है. Okay, so let me just quickly tell you about this. Those of you who are following us on the JEE English channel of YouTube can connect with us on the Telegram app using this link so that you are sure that you're not missing out on any of the lectures and sessions happening on this channel. Okay. So now, before we get started with today's review discussion, let's address the problem that okay, yeah. So here it is, right? That is the question, right? A aircraft is descending to land at an airport in the morning. The aircraft is landing to the east, okay, so that the pilot has sun in his eyes, okay. So the aircraft has speed v and is descending at an angle of alpha, okay. The sun is at an angle of beta above the horizon. Find the speed of the aircraft shadow moves over the ground. Okay, okay, all right. So let's just add a page. Okay, let's try and out. So you have a plane. Okay, so let's say you have a plane here, and this plane is landing towards east. So this is getting down at an angle of alpha, correct? Now you have the sun, which is here somewhere, and this is at an angle of beta, correct? So like this angle beta. You have to find the speed of the shadow of the aircraft, right? Okay, lag plus material lead. Hmm. Okay, no worries, no worries. Correct. Okay. So what will happen is that imagine this plane is moving like this with a speed of v, and if you talk about the shadow, right? Consider a light ray यहाँ आ रहा है और ये गया ये गया यहाँ पर आपका shadow बना, right? Now all you need to do is figure out the ratios of these. So एक बार ये angle और ले लेते हैं. You will realize this angle would be alpha. Okay, and this is where the shadow is formed. This is beta, correct? Correct. So what I can say is, if I talk about the horizontal velocity of plane, hmm, so I can say that I can divide this velocity into two components, this and this. Now, because of these two velocities, let's have this angle. Okay, this is y, this is x, and I can say what I can say is tan of beta, tan of beta would be equal to y over x, correct? Okay, wait. Can I say that? Okay. Now, what I can also say is that for this point again, as it moves. as it moves, happen to this shadow. Shadow also moves forward, right? As it moves like this. So I need to relate these sides. I want to relate this side, the triangle, and this side of the triangle. All right, let's see. Let's see how we can do that. What we can do is okay. Let's take a look at the bigger triangle. Okay, let's draw the bigger triangle first. In this. Now this is a fixed point towards which the plane is flying. Okay, ये इससे फिक्स पॉइंट की तरफ बढ़ रहा है और ये आपका एंगल बीटा है और ये किसी तरह बढ़ रहा होगा यहाँ पर. तो दिस इज बीटा, दिस इज अल्फा. ये एंगल क्या हो जाएगा? y minus alpha minus beta, correct? So what I'll see is that if ये साइड आपका x है और ये कुछ let's say y है, बल्कि ये कर देते हैं, ये z है. So I can use and relate them using the sine rule, right? Sine rule से relate करते हैं जरा. So can I say x over sine of alpha plus beta would be equal to z over sine of beta, correct? अब इसको differentiate कर दो बस simply. dx over dt would be equal to sine of alpha plus beta over sine alpha times dz over dt. And dz over dt आपका v है और ये shadow की velocity है. Velocity of shadow would be sine of alpha plus beta over sine of beta है यार, of beta alpha नहीं, times v. ये आ जाएगा यार रिलेशन मेरे हिसाब से तो. हम्म. Okay, let's see क्या आंसर कहाँ गया यार. v का cos alpha plus sin alpha plus cos beta. ओके, तो उस फॉर्म में लाना पड़ेगा किसी तरह. हम्म. लेट्स सी. साइन अल्फा प्लस बीटा को जरा ब्रेक कर दो. से v of s, v of sin of alpha plus beta is sin alpha cos beta plus cos alpha. ये आया v plus cos of. हम्म. सो ऐसा आई गेस कुछ फॉर्म आएगा. ठीक है, इसको रीअरेंज करोगे तो शायद उस फॉर्म में आ जाए. वो कुछ रीअरेंज ही हुआ होगा और कुछ नहीं है. ठीक है. ओके, और उससे ज्यादा कुछ नहीं हो सकता. All right. Anyways, so let's get started with today's discussion फिर. ठीक है. Yes. ठीक है, बाकी बाद में उसको देखना उस फॉर्म में रीअरेंज हो सकता है कि नहीं, बट आई थिंक दिस इज हाउ यू शुड बी एबल टू डू इट, ओके? ऑल राइट। Now, so let's get started with today's discussion of SHM. So before starting SHM, we need to talk about periodic motion and oscillatory motion also. So you know what a periodic motion is: whenever a body is moving such that it repeats its motion along a definite path. So please remember these are the keywords. So the motion repeats itself along a definite path after regular intervals. Then such a motion is called a periodic motion. Okay, and the interval of time is called the time period. Okay, again, so any motion that repeats itself after. Okay, bye bye. All right. Yes, absolutely. Any motion that repeats itself after regular intervals of time, again, along a definite path, so it should have the same path, repeat the same path, and repeat it after regular time intervals. Then such a motion is called periodic motion. Now you realize the importance of periodic motion in our lives is because of everything in our life is periodic. The rotation of Earth about its axis is periodic. So because of which we have, our entire life, which is periodic, divided into days and nights, right? Similarly, your revolution of the sun, of the Earth around the sun, is also periodic, because of which you have your periodic cycle again of years. So periodic motions have a lot of importance in our life, and in fact, our life runs in periodic circles, right? So that is why periodic motions are of great significance to us. Now, similarly, there is something which we call the oscillatory motion. Now, oscillatory motion is a special type of motion in which an object performs to and fro motion about a mean position. So there is a mean position, okay, and about which there is to and fro motion happening. So to and fro motion meaning that something goes in either direction of this. Okay. So again, so this is what you call oscillatory motion. Okay. Now, why will a to and fro motion about a mean position happen? It will always happen under the influence of something which we call a restoring force. Okay. So there has to be a force that will always try to pull this thing towards the mean position. So whenever it is going in this direction, you realize the force has to be in this direction. Whenever it is traveling in this half, the force has to be in this half. So such a force is called a restoring force. So a restoring force will ensure that anything performs an oscillatory motion. Now, simple harmonic motion is the simplest periodic oscillatory motion in which the object oscillates between two spatial positions for an indefinite period of time with no loss of mechanical energy. So that is a specific case of oscillatory periodic motion. Okay, that is SHM. Next, so let's talk about the oscillatory motion in a slightly detail. Okay, slight detail. So you know that to and fro motion is what we call the oscillatory motion. Now, in such a motion, a particle moves about a stable equilibrium position. Okay, all right. Okay, Shivam, no worries. All right. So there has to be a stable equilibrium position. Why? That by definition, a position of stable equilibrium is one. If you disturb an object from the stable equilibrium position, then it will try and come back to that position. Okay. Now, please note that this motion does not need to be periodic. Okay, and need not have fixed extremes. So in practical life, what happens is that if you have a block connected to a spring, correct, and you leave it, if you oscillate it and leave it, you realize practically what happens is that it may start with such a time with such an amplitude, then its time period goes on reducing. Okay, so it will eventually slow down and eventually come to rest. So for the entire duration, you will realize the motion is oscillatory, but it is not periodic. Why? The path is changing and the extreme positions are changing, right? So that is why I'm saying that all oscillatory motions need not be periodic. For periodic motion, you have to follow the same definite path and with the same regular interval. So practically, you realize the interval might also not remain the same. Okay, for this kind of a case. For instance, if you talk about a ball which is bouncing from here to here, let's say, which is bouncing between these two walls and undergoing some collisions with some coefficient of distribution E. then you realize for this, the extremes are fixed, but the period will keep on changing. The motion throughout will be oscillatory about a certain position, but the period is changing. So this motion is also not periodic. Okay. Now, oscillatory motions in which energy is conserved are always periodic. So that is again a requirement. So if the energy is conserved in an oscillatory motion, then it is periodic. So if here E becomes 1, if in this case E becomes 1, if all the collisions are perfectly elastic, then the period remains definitely the same. Similarly, if there is no dissipation of energy, okay, practically, if we consider a hypothetical ideal scenario, if there is no dissipation of energy in this case also, then this represents an SHM, which is a periodic motion. Okay. Now, for such periodic motions to happen, a conservative restoring force has to be there. So you do realize for such a to and fro motion, periodic motion to be happening, there has to be a conservative force. Okay, because there has to be no loss of energy and there has to be a restoring force which will cause this. So such a force in general can take this form. Okay, F equals minus kx to the power n, where n is an odd integer. Okay, so imagine you may have forces, you may have a force which is F equals minus kx. So if you talk about this position as the origin, now what you'll realize is as soon as the object is traveling in this direction, the force is in this direction. Okay. And when the object is traveling in this direction, the force on it would be in that direction. So this will act as a restoring force, correct? And this will always try to bring that particle towards the origin. Similarly, you could have considered another force, F equals minus kx cube. Now, this kind of force will also show this behavior. It will also act as a restoring force which will try to bring the object back to the origin. Again, you could have had this force as this form and so on. So any odd power of x would have ensured that you have a restoring force which will cause oscillatory motion about a mean position. Okay. Now, one special case of this kind of restoring force is what we will consider in SHM. Okay. So that, okay, page did not shift. So, okay. Okay. So a special case of such a motion, such a restoring force is if the restoring force takes this form, equals minus. Okay. Now this is the simplest form of oscillatory motion with the simplest restoring force governing this motion, and that is why you use the word simple harmonic motion to describe this. Okay. Uh, is these which year chapter? So this is SHM for class 11th. So the topic is class 11th. This is mainly for revision. Okay. This is mainly for revision and some key concepts. Okay. All right. So as I said here, k is a positive integer, a positive constant, and x is the displacement from the mean position or the equilibrium position. Okay. So this kind of a restoring force will govern a motion which we call SHM. Okay. Simple harmonic motion. Again, harmonic means periodic. The word harmonic means periodic. And we are using the word simple because it is being governed by the simplest form of the restoring force. Okay. Now, SHMs are usually of two types. They may be linear and they may be angular. So, linear SHM is when the motion is happening along a straight line, and angular is when something is rotating about an equilibrium position like this. So, there are two kinds of SHMs that we will talk about. Okay. Now let's go over the basic definitions. Okay, so one, there is definitely mean position. We have been talking about this. So it is the position about which the to and fro motion is happening. Okay, so the restoring force is always at this position is zero. It is always in fact directed towards this position, and when this position is reached, that restoring force is zero. So this you can say is the equilibrium position. Okay, and it is always the midpoint of the two extremes. Okay, so you will have a mid position, mean position, and then you will have extreme positions during this to and fro motion. So it is always the midpoint of these two extreme positions. Okay, so if these are the two extremes, you find the mean position at the middle of the two extremes. Okay, then there is amplitude. Obviously, this is the distance between the mean position and either of the extremes. So this distance or this distance, this is what we call amplitude. Okay. Next, a particle under SHM is bound to remain between two extreme positions. So any particle which is performing SHM will only be restricted to move in this region. It cannot leave this region. Okay, this range is its range. It's bounded in that range. Okay. Now the speed at the extremes therefore is zero because it cannot go beyond the extreme. It has to turn its direction at the extreme. So at the extremes, its speed is always zero. So remember these points. Next, the mathematical equation of chaos governing this motion is as follows. You know, since F equals kx, we write A equals in the form of, this is a traditional way of writing this, A equals minus omega square x. Okay, traditionally we write it like this. And please note that this is the necessary as well as sufficient condition for SHM. So necessary means without this SHM cannot happen, and sufficient means if this is true, then you don't need any other thing. This alone itself is enough to cause SHM. Okay. So whenever you have an acceleration which varies with respect to the displacement in the form of A equals minus omega square x, so we are using omega square because omega square, you know, will always be positive. Okay. So this will be any motion which has equation like this will be an SHM. Now further, what you can do is if you integrate this, you will have different equations. Okay. So you can, if you integrate this, what you will find is that after integration, you will find the expression, uh, the expression for displacement like this. Again, we are not going through the integration because this is a revision class. I'm just writing down the expressions. Okay. And of course, differentiating that, you will have the expression for velocity like this. And differentiating that, you will have the expression for acceleration like this. So these are the three standard forms of the equations of SHM. Okay. Please remember this. Again, if you don't remember, then now remember it. Okay. This is just for revision. All right. Now, if you look at the graph, this is what the graph would look like. So displacement, velocity, and acceleration graphs, these are again in accordance with the equations that we just derived. So the first one, displacement graph, you will realize is a sine graph. Second one, velocity graph, is a cos graph. Finally, the third one, the acceleration graph, is the minus sign graph. Okay. Next, you can also try and relate the velocity with the with x and the acceleration with x. So what you will realize is that the velocity and the acceleration or the displacement are related like this: omega times root a square minus x square. Okay, this is a very important form. Again, you must remember this. Okay, very important. You will be using this a lot, a lot. Okay, now with the help of this, I can also draw a graph between v and x. So if I just look at this, I can rewrite this as, right, which essentially takes the form of, right, you know, this is the expression for an ellipse, right? So if I draw the graph between x and v, you will realize I have this kind of an ellipse, right? Where this position would be plus a, this position would be minus a, this position would be plus a omega, this position would be minus a omega, right? So the graph between v and x is that of an ellipse. Again, important because there are sometimes questions asked on this graph also. Okay, please note that this is also important. I am only taking up things which are important, okay, which you must remember. Now, of course, you realize the relation between acceleration and displacement was already like this. Okay, so what you have is the graph between them would be a straight line passing through the origin with negative slope. Okay, where you will realize tan theta would be omega square. So again, This should be simple. This is theta, then tan theta, of course, right? Okay, so just remember these. Next, again, we will talk about some more definitions. So, one complete oscillation. So, the motion starting at any one point and coming back after having been to all possible positions is called one oscillation. Imagine if the particle is moving about the mean position. Let's say here is the mean position. Okay, and here are two extremes. One extreme here, one extreme here. Okay, imagine this is the entire range of motion. Okay, now what you will realize is imagine if the motion starts at this point and it is happening like this. So when it moves from here to here and then back and then back and then back and then back. Now that is what you will call one complete oscillation. Now it has built to all possible positions in the range of motion. Okay. So when the object or the particle comes back to the point of start after first time, that is after being to all the possible positions of the range, then that is called one oscillation. Okay, now time period obviously is the time taken by the particle to complete one oscillation, and frequency is of course the number of oscillations per unit time. So if the time period is t, you will realize that mu is 1 over t. That is the relation between time period and frequency. Okay. Next, we have something which we call phase. Now, the argument of the sine or the cosine function is what we call the phase of a particle executing SHM. Now, the phase tells us about the state of the particle at any instant. Okay, so again, as I said, the equation of displacement, if you remember, was of the form this, correct? Now, this is what you call phase. This expression is called the phase of motion. What is that telling you? If you look at the graph, it is essentially telling you in this motion where it is. Phase is representing where it is during this motion. Okay, you can realize the angle turned by the graph. That is what the phase of oscillation is. Okay. Now we will again talk about the significance of that in a bit. Okay, in a bit we will talk about the significance of that. But right now, all you need to know is this is what you call a phase of SHM. Okay. Now, then you have angular frequency. Again, the rate of change of phase is what you call angular frequency. If you realize this expression, this phase is changing at a rate of omega, right? d phi by dt. This phase. Okay, so this is usually called phi naught. This is usually called phi naught, which is called the initial phase. Okay. So you realize the phase is changing with respect to the angular frequency omega, and you realize omega is also related to the frequency of oscillation as omega equals 2 pi nu. Okay, or time period is 2 pi over omega. So again, important relations must remember. Again, we will talk for those of you who are in class 11th. We will talk about this in detail when we are discussing this for class 11. This is just a quick review, so I'm just quickly revising all the key terms. Okay, now here is a question for you. Which of the following equations represents an SHM? Okay, so try and answer this. ये वाला बता दो जल्दी से. Okay. So you have four expressions here. Which of the following represents an SHM? So more than one correct, by the way. Okay, so try and answer this. So hurry up, hurry up. बताओ बताओ भाई, जल्दी बताओ. Okay. How long would the session will be? So the session would get over in another 50 minutes or so. 45 minutes, let's say. So I usually take 1.5 hour sessions. Okay, 1, 3, and 4. Yes, all of you guys are right. No, Grish, all are not correct. All are not correct. B is B is not SHM. Periodic. This is periodic, but not SHM. Okay. So only A, C, and D represent SHMs. Okay. So Kavita Reddy is right. Definitely. AP is also right. Okay. So simple test. Simple test. Please realize, guys, whenever you're asked whether a function represents SHM or not, you know what is the necessary and sufficient condition? That d2x over dt2 should be of the form of minus omega square x. If you have this form, then that expression will represent SHM. If this form is not there, then the motion is not SHM. It may be periodic, but not SHM. Okay. Okay. I hope you guys figured that out. Okay. So you can test this for all your equations. You will realize that equation number 1, 3, and 4 do satisfy this. Okay. Second one doesn't. That is why second one is not SHM. It is periodic, but not SHM. Okay. Girish. All right. Now let's try another problem. Okay. So here you've been told a particle of mass 2 kg is moving along a straight line under the action of a force which is 8 minus 2x Newton. Okay. It is released from rest at x equals 6 meters. Find the mean position, find the find the expression for velocity with respect to time, and find the time period of this motion. Okay, so let's get some practice. Come on. Hmm. Let's see. Where is the mean position first of all? Where do you think is the mean position? The mean position should be easy to find. I told you what are the properties of the mean position. How can you identify the mean position? I told you two, three things, right? First, mean position is the midpoint of the two extremes. So you only know one extreme here, you don't know the other extreme. What is the other thing about mean position that we know? Mean position is an equilibrium position. Remember? So try and now I've given you enough hint. You can find the mean position, I'm sure. Right. Let's see. Let's see. So quickly tell me the mean position. Okay. Come on, people. This is an easy one. Why are you guys taking so long? Mean is x equals 4. Yes, Girish. Girish is absolutely right. Yes, AP. Finally. Finally. Correct. Correct. You realize that for mean, it is the equilibrium position. So we know that F equals 0 at mean position. So that will simply give you 8 minus 2x equals 0. So x equals 4 is the mean position. So that is your answer for part A. Yes. Okay, so what Arnav is saying, sir, can you teach Taylor's method for SHM? It is written in Engage, Cengage, and was used in JEE Advanced 2020. Okay, so where does it say that that any problem cannot be solved without that method? Okay, I don't think that you will be ever compulsorily needing that method. So why complicate your life? Okay. There are a lot of methods to analyze things. There is a lot of mathematics that you can use, but again, not really necessary. Not necessary. Okay. But if you still insist, maybe okay, I will teach it. Okay, Arnav. Okay. Next, honestly, I never use that method. Okay, I don't know what Gage has given, but I will see. Sure, it's nothing new. Okay, all right. And that problem of 2020 that you're saying, I'm sure I can solve that problem without using any special methods. Okay, maybe I'll take up that problem also in the quick review. Okay, Arnav. All right, all right. Next, let's talk about the point number two. So you have to find the expression for velocity with respect to time. Now you realize from this expression, I can find the expression for acceleration. Acceleration obviously would be 4 minus x, correct? So if acceleration is of the form of 4 minus x, what I realize is what is omega? Omega is 1, correct? Hmm. No, you have to find that. Okay, okay, definitely I'll see. Okay. So you don't have to give the answer in terms of x, Girish. Not in terms of x. In terms of time, you have to give. No. Okay. So I'll tell you. I'll tell you. You already know the omega. Now you know the expression for velocity. Expression for velocity is usually of the form v equals a omega sine of omega t plus phi. Correct. That is the usual form. All right. Now you also know the a. How much is a? A is 2. 6 minus 4. Because I know x equals 6 was an extreme, right? It started from rest from here. So x equals 6 was an extreme. The amplitude is 2, right? Amplitude is 2, omega is 1. So I all I need to know is the phi. For phi, I also know also t equals 0 at t equals 0, correct? So that will tell me phi equals pi by 2. So sorry, phi equals 0, correct? So obviously what you will realize is that v equals 2 sine t. That is the expression. Correct. I don't want the expression in terms of x. I want it purely in terms of time. Girish. अरे बाबा it's this 40 minus 60 नहीं होगा ना वो नहीं होगा. Even if you had to tell in terms of x, I will tell you how you would have. Okay, this is the expression. This is the expression. Okay. Now even if you wanted the expression for this in terms of x, this is what the expression would have looked like. So v equals omega times root of a square minus x square, correct? Omega is 1, root of 4 minus x, and x coordinate you would have taken x minus 4. This is what you would have had. This would have been the expression of velocity in terms of x also. Okay, great. Next, find the time period of this oscillation. No, this is very simple. हाँ इसमें तो कुछ है ही नहीं. T equals 2 pi over omega. omega आपको पता ही है 1, so 2 pi seconds आंसर हो गया. Correct. So this is how we would have answered all these three questions. Okay. All right. So let's try one more problem. Okay. You've been told a particle executes simple harmonic motion between x equals minus a and x equals plus a. The time taken to go from 0 to a by 2 is t1, and that to go from a by 2 to a is t2. find the ratio of T1 is to T2. Again, this is a standard result which you can even memorize after you calculate. Okay, we use this a lot. Use this a lot. Okay. See, let's see if we can figure this out. Hmm. Okay, hurry up, let's see. Okay, so time taken from 0 to a by 2 is T1, and from a by 2 to a is T2. You have to find the ratio of T1 is to T2. ये कर दो जल्दी जल्दी. Again, a standard result which you should remember also. Okay. So hurry up. I'm surprised some of you don't remember the result. Okay. Hmm. Okay, anyone? All right. तो ये नहीं समझ में आ रहा किसी को भी. Okay. So should I go ahead and solve? Okay. Okay. So why don't I go ahead and solve? So let's assume that the equation of displacement is x equals a sine omega t. So obviously at t equals 0, this starts at origin. Agreed? So let this at t equals 0, I know particle starts at origin. Now, what you know is at time t1, the particle is at a by 2, correct? So AP says 1 is to 2. Okay, let's see if that is correct. Also, we know at e equals t1, x equals a by 2, correct? Now, what you will realize is that all I need to do is just substitute those values. Now, if I substitute those values, a by 2 would be equal to a times the sine of omega t1. Correct. So from here, I will realize this and this goes. What I'll realize is omega t1 equals sine inverse of 1 by 2, that is pi by 6. Correct. Okay. So what I'm getting is t1 is pi over 6 omega. Right. इसको हम क्या लिख सकते हैं? Or I can write t1 is capital T over 12. Capital T being the total time period. Correct? Hello Arjun, how are you? Okay, so I hope you guys realize that I can write t1 as t by 12. Right? Because capital T was 2 pi over omega. So this is nothing but 2 pi over omega by 12. Correct? I was about to join, but I forgot. Oh, okay, no worries, no worries. You can watch the recorded thing later. Now you also know from reaching from 0 to plus a, how much time will it take? So if the total time period is t, then while going from here to here, it will take t by 4. Then while coming back, it will take t by 4, and so on. Agreed. This this you should know. This you should figure out immediately. So time for particle to get from a by 2 to a, that is t2, that should be equal to by 4 minus t1. Great, very, very simple. Okay, so again, this I can write as 3 times t by 12 minus t by 12, so that is 2 by 2 times t by 12, correct? So the ratio is in fact 1 is to 2. Very well done. 1 is to t2 is coming out to be. Okay, so yes. Hello, Manoj Kumar. 1 is to 2 is the right answer. All right, this is a very standard result, which now you should memorize. Okay, whatever time it takes from getting from a to a by 2, oh, sorry, 0 to a by 2, it takes double that time to reach from a by 2 to. Now you know here the velocity is b, here the velocity is 0. So you realize the average velocity for this duration is higher, the average velocity for this duration is lower. So obviously that duration should take a longer period of time. Okay. All right. I hope logically also you should remember 1 is to 2. It's very simple to remember. Okay. Easy standard result. Again, just go through the solution and let me know if there is any doubt that you have. Okay. Okay. So if everything is clear, should we move ahead then? All right. All right. Let's have one more problem. Okay. This is the final problem that we'll have. Omega equals 60, 30 implies period 1 is to 2. Yes. So we will come to that also, that approach. We will come to that. That's not omega, that's theta. You're talking about theta, omega into t. Theta is 30 degree and 60 degree. We will come to that approach in a bit. Yes, Girish, you are absolutely right. Okay, that approach we will come to in a bit. Okay, we still haven't talked about the circular equivalence of this. Correct. So that is why I haven't told you that solution. Okay, that is why I presented the mathematical solution first. Okay. Now let's talk about one more problem. Okay. So in this problem, you've been told a particle performing SHM has a maximum velocity of 6 meter per second and the maximum acceleration of 4 meter per second square. Find the time period and the amplitude of this SHM. Okay, so you can figure this one out. You've been told the maximum velocity, you've been told the maximum acceleration. What do you think is the time period and the amplitude? Okay, let's see. Okay, I hope you guys remember what the maximum velocities and the maximum accelerations are. Okay. Now again, very very important, and you must remember that. Okay. So if in case you don't remember, let's go over that from here. You realize these were the expressions, right? These were the expressions. So what do you think is the maximum velocity? Is not V max, not V max is A omega, and A max is omega square A. Okay, so this you should remember. Very, very important. Okay. Now with that, you should be able to solve this. Okay. Again, you can see that from this graph also. This graph also you can see that this is minus omega square x a and this is omega square a. Okay. So I hope that helps you. And now you will be able to tell me the answer for this. है ना? अब तो कुछ भी नहीं है. Let's see. Hello, Kushal. How are you? Yes, absolutely. So 3 pi. That would be the time period. What about the amplitude? What about the amplitude? Yes. So great, great, great. So you just needed a little bit of reminder then, है ना? See, I told you. Once you remember that, it is easy. Okay. So of course, V max has been told to us. V max is omega A, which is equal to 6, I guess. That has been told. I know A max is omega square A. I'm only talking about the magnitudes here. So this is this. So if I divide these two, so what will I get? 1 over 2, 2 over 1 gives me that omega is 2 by 3. So obviously time period, which is 2 pi over omega, comes pi. So absolutely correct. Now, how about the amplitude? Amplitude is very, very easy to see. All you need to do is you find square of 1. Square the first equation divided by 2. If you square the first equation, you have omega square A square divided by omega square A, that'll be A. Equal to 6 square over 4. Correct? Okay, so that'll be 9. Correct? I hope you guys followed this. So long time, Kushal. Where have you been and how have you been? I hope you've been safe and sound. I hope everybody followed this. Is there any confusion about this? No. There is no pi in A. No. नहीं भाई गिरीश क्या कर रहे हो? Pi कहाँ से आ गया? Square this. Square this. This will tell you omega square A square equals 36. Now divide with this. Okay, A is 9. 9 meters. Okay, गिरीश pi नहीं है 9 meters है. Let me know if you followed that. This is the answer. Okay. Clear? Let me know so that I can move ahead. It's not 2 by pi. Okay, so 3 pi was yes, A equals 9. Okay. All right. Great. Great. Now we also will realize that any SHM can be seen as the projection of a circular motion. So any simple harmonic motion can be considered as the projection of a circular motion. What I'm trying to say is, so for those of you who don't know what the projection is, so imagine a hypothetical object, which is moving in a circle. Imagine an hypothetical object moving in a circle of radius a and rotating with a constant angular velocity omega. Okay. Now imagine that. Imagine that. Now projection, should is the height of the shadow. Okay, where you will see the shadow. So imagine if somebody wants to understand projection. Imagine light is coming from here. So if light is coming from here, then you realize the shadow of this would be here. That is called the y projection on the y-axis. And sometimes we talk about x projection also. Then for x projection, you consider light falling perpendicular to x-axis. So if light was coming like this, then you realize the shadow would have been here. This is called the X projection. Okay. This is the X projection, and this is what we call the Y projection. Okay. So now imagine any particle like this that is moving in a circle, okay, in a radius a. So at any time t, okay, so imagine at the time t equals 0. Here I've assumed that at time equals 0, t equals 0, it was here. Let's imagine. So this was the angle which is phi naught, which is the angle at it was at time t equals 0. Now in time t, it would have rotated by an angle of omega t. Correct. So this entire angle turns out, this entire angle would become theta would be equal to omega t plus phi naught. Correct. So what is the height of this y projection? You will realize height of the y projection at this point. Obviously, if you look at this triangle, all you need to do is look at this triangle. So this is a, you know this theta, you know y would be equal to a sine theta. Great. So I can say y would be equal to a sine of theta. And what you realize is that theta I already realized was omega t plus phi naught, correct? So I can write this as y equals a sine omega t plus phi naught. Now this you realize was the motion equation of SHM. So what I'm trying to say is, so every time you see some SHM happening, you can imagine an imaginary particle is moving in a circle, and you realize what its shadow will do. As it is moving in a circle, its shadow would perform SHM. Okay, so that is what you can visualize your SHM as. Okay, SHM can be visualized as the shadow, movement of the shadow of a particle, hypothetical particle moving in a circle. So imagine if this is what this guy was moving. If a particle was moving in a circular path with a constant omega, then its shadow you will see will be following the SHM equation. Okay. So now this turns out is a great way for us to visualize the system and solve problems as Girish was saying. Okay. So now you understand what the phase is or the initial phase is. Initial phase was the angle that your rotating particle is making with the x-axis at t equals 0, and your phase is the angle that your rotating particle's radius vector is making with the x-axis at any time given time t. Okay. Now what you will realize is that with that help I can also derive all the expressions for SHM. So I already derived the expression for y, correct? Suppose if I had to derive the velocity equation, okay, so again that is very simple. So you realize if this particle was moving in a circular manner, so this v would have been equal to omega times a, correct? And that would have had two components, right? If this was theta, this was theta, this was theta, so it would have had one component like this, v cos theta, and another component like this, v sin theta. So the velocity of the shadow, you realize how much would be the velocity of the shadow? Velocity of the shadow would have been this component of the velocity of your rotating particle. Agreed? So can I say for the particle performing SHM, for the particle performing SHM, I can write the velocity as v equals omega a cos of theta, or I can write this as omega a cos of omega t plus phi naught, which was the equation which we would have gotten after differentiating that also. So you realize everything is analogous. So the velocity of the shadow is this. Now let's talk about the acceleration of the shadow. Now since this guy is moving with a constant omega, so it has no tangential acceleration. The only acceleration that this particle will have will be centripetal, correct? It will have a centripetal acceleration of omega square a, right? Now again, I can divide this into two components, one along this line and one along this line. So what is the acceleration of the shadow that I'll see? I'll see this component. So you realize this component would be omega square a sine theta. Okay. So you realize I can derive all the expressions of SHM from this analogy. I can say similarly, acceleration would be omega square a sine theta. And what you realize is it is directed downwards. It is directed downwards. So that is why I have a minus sign. So I will add a minus sign because this acceleration is downwards. When the particle is moving upwards, the acceleration is directed towards the negative y-axis. Okay, sine theta, or I can say minus omega square a sine of omega t. That's fine. So now all you need to do is remember this analogy and you can derive all the expressions from there also. And obviously you will realize that the maximum velocity would be here, which would be this, obviously, the A. Maximum acceleration similarly would be here, that acceleration directed like this, omega square A. Okay. So I hope everything that I'm saying is easy to see and follow. Okay. So now this is a great method of visualizing SHM, understanding SHM, and then solving problems related to SHM. So as Girish had initially said about our question, okay. So the question where I asked you what is the time taken by the particle to reach from A to A by 2 and 0 to A. Okay, remember that. Let's try and solve this using this now. Let's imagine our hypothetical particle performing circular motion. Now, what you will realize is our hypothetical particle starts from here. So this is at t equals 0. Right? Equals 0. Now at t1, it reaches, the shadow should be here, a by 2. So where this is a, the shadow should have reached here, a by 2. So you realize the particle, rotating particle would have reached here, correct? At equals 1. Right, so I know from the geometry, from this geometry, I can say, I see this. This is a by 2. The perpendicular is a by 2. The hypotenuse is a. Of this angle, obviously, is 30 degree. Correct? Okay. So from here to here, so from here to here, particle takes time t1. Now from here to here, the particle takes time t2. To reach the extreme, our rotating particle must have reached here. Okay. So what is the angle turned by the rotating particle? So from here to here, the rotating particle turns an angle of 60 degrees. Okay. Now, using the analogy of circular motion, I can immediately say T1 would be pi by 6 omega and T2 would be pi by 3. Okay. So in reaching from here to here, particle turned by an angle of 30 degrees, which is essentially pi by 6. Okay, and the time required for that would be theta over omega. Simple. Constant omega से move कर रहा है, so सीधा angle over the angular velocity. That'll be the time. Similarly, T2 time में it turns by an angle of 60 degree. Okay, or pi by 3. So the time required would be pi by 3 omega. Okay, so again, this makes our problem solving pretty easy and saves us from a lot of maths. If I can just have basic geometry, then following basic geometry, I can save time also at times, and I can especially avoid maths, which I prefer at least. Okay, but never too comfortable with maths. All right, so let's try more examples of this. Okay, let's try a few more examples of this. So here you've been told two particles P and Q are performing SHM along the same line with the same amplitude and the same frequency. When P is at a distance of a by 2 from the mean position and is moving towards extreme, Q was found. It was found that Q was at the same position but moving towards the mean. Find the phase difference between the two SHMs. Okay, so do this. Hurry up. What will be the phase difference between the two SHMs? Yeah, hurry up. Again, easy enough problem if you use that analogy. If you use the circular motion analogy, this is easy to answer. Okay. Let's see how many of you can figure this out. Until the time you guys are trying this, let me help myself with some water. Okay. So again, a standard problem solved very easily with the approach of circular motion analogy. Okay, so AP says 2 pi over 3. Okay. Anybody else? Anybody else trying to find the answer for this? So let me just wait for one more minute and then maybe I can show you the solution. By the way, AP, you are right, it turns out. Okay. So let's see. Okay. Just go ahead and get this done. So imagine again, I will draw this circle. Okay. I'll draw this circle and then I'll try and figure out what is happening. So I've been told at initially they are moving with the same amplitude and the same frequencies, which means their amplitude and the radius of the circular motions would be same. Agreed? Same amplitude, same frequency means radii and omega of the circular motion are same. Correct? Now you've been told when P is at a distance of a by 2 from the mean and moving towards the extreme, Q was found to be at the same position but moving towards the mean. Yes, 120 is the correct answer, Girish. Alright, so when P was here, imagine is so here is imagine a by 2 plus a by 2. So if this is a, this is a, then here at a by 2, when P is here, right? P is if P was here, and the line joining P and this was rotating like this, then P is at a by 2 and moving towards the extreme. Okay. At the same time, where would Q be? This is P. How about Q? Q, if I draw Q here, moving towards this and with omega, then it is also at a by 2 and moving towards the mean. So which software are you using? Okay, so this is software for iPad called Notability. I find it very easy to write, and anything that I'm writing on my PDF gets stored also. All my handwritten notes get stored very easily. Yeah, yeah. Anyhow, so obviously, what you realize is from this triangle, that both these angles are 30 degree each. Correct. So this is 30 and this is 30. So the phase difference between P and Q is this angle, which is in fact 120 degrees. So Girish was absolutely right. So the phase difference delta phi equals 120 degrees or 2 pi over 3. So we usually like to report our answers in radians. Okay, Girish. So that is why it is better. It is just better to report it as a 2 pi over 3. Okay. All right. So I think we can conclude our discussion here. This session was supposed to be till 5:30 only. So we will start this new discussion about energy of the SHM in the next class, which we will take tomorrow. Okay. Tomorrow we will start with that discussion. First, let's bring today's session to a halt. Okay, and we will continue this discussion tomorrow, same time, 4 o'clock, where we will talk about energy of SHM and then solving problems of SHM. Okay, all right. Now, before I wrap up today's session, let me remind you, if you haven't gotten your Unacademy subscription, if you're planning to get it, and then this is how you can do it. Okay, you can go to the plus section of the Unacademy app, select your goal as IIT and click on that get subscription button. Okay. Now, when you do that, you'll be redirected to the payment page where you will have a box that will say, do you have a code? So there is where you can fill in this code RD Live, and this code will give you a 10% off on your subscription fees. Okay. Now you can also choose from two kinds of subscriptions now, which are the Plus and the Iconic. The fees of these subscriptions are as mentioned here. You will also realize that when you click on proceed to pay, you can choose from a lot of no cost EMI options to break this payment into easy installments, no cost. Okay. Now, those of you who do not know what the iconic subscription is, so this is a new feature that Unacademy offers now, and this subscription will take your IIT preparation to the next level. And how does that happen? So you'll be allotted personal coaches from our team of experts. So these personal coaches will closely monitor you and mentor you throughout your IIT journey. Along with personal coaches, you will get to attend a lot of IIT workshops. You'll be receiving timely expert guidelines, getting a study planner, and a test analysis sessions. Okay, so with all these benefits, you will definitely power ahead in your IIT journey. Okay. Now, those of you, the students that are yes, bye bye AP. So students who are now have just come to class 11th, and those who are looking for a single stop solution for all their studies for class 11th, 12th, and JEE can now opt for a combo subscription that Unacademy is offering. So this combo subscription will take care of your 11th CBSE studies, so your school examinations, your 12th CBSE studies, so your board examinations, your IIT JEE Mains, your IIT JEE Advanced, everything is taken care of with this combo subscription. So one single stop solution for your study needs. Okay. So four kind of combo subscriptions are available. Okay, so in the first combo, you have the iconic subscription for IIT JEE and the plus subscription for CBSE. Okay, this subscription starts at around 4,600 a month. Then you can choose for a combo which offers the iconic subscription for all three. This combo starts at around 5,500 a month. Then of course you can choose a combo which offers a plus subscription for all three. This starts at roughly 3,000 a month. And finally, you have a combo offer where you can choose plus subscription for IIT JEE and iconic subscription for 11th and 12th. And this combo starts at around 3,900 a month. Okay. Now, these are the upcoming tests in January, which you don't want to miss out on. Okay. So the Unacademy Combat is going to happen on the 17th and the 31st of Jan. Make sure you're taking part in that, doing well and winning yourself some really cool prizes. Then the next race test is going to happen on the 24th of Jan. Last mile test already happened. Aim advance every Saturday it is happening, and then you have unique PPP decisions which are happening every Monday to Thursday. Okay, so make sure you are being a part of all these. Okay. Now, if you like today's video, if you like this session, do not forget to press the like button and do not forget to share it with as many people as you can. Okay, so Unacademy is providing you quality free content. Okay, here for those of you, we realize that not all these students can afford these subscriptions, but we want a quality education to reach as many students as possible. So to this channel, we are trying to promote it completely free of cost to make sure that more and more students benefit out of this. Make sure that you're sharing the this with all your friends and everybody that you know who you think is this. Now, if you're new to this channel, don't forget to subscribe, okay, so that you can keep receiving all the amazing content available on this particular YouTube channel. Don't forget to press the bell icon also. And the PDF of all the slides used in today's lecture would be available for download very soon. Okay. Now, those students who are following us closely on the JEE English channel of YouTube. You can also connect with us on the Telegram app using this link. That will ensure that you are getting all the timely notifications of every lecture and session happening on this particular channel of YouTube. Okay. Okay, with that, we will wrap up today's session then. And before I leave you guys, let me remind you one last time that this is my code RD Live. So if you are planning to get your subscriptions for the Unacademy Plus, you can use this code and enjoy a 10% off. Now we will continue our discussion of SHM tomorrow, okay, and we'll carry forward from where we are leaving it today. So make sure you're joining me back tomorrow at 4 o'clock again. Okay, till then, you guys keep practicing hard, keep studying hard, and take care of yourselves. Bye bye.